Hi everyone. So today let us continue from our previous series of machine learning crash course offered by Google. So today we have under the classification ROC and AUC. So ROC is a receiver operating characteristic curve and AUC is the area under the curve. Curve in the sense that ROC curve that is. So what is an ROC curve? So in the previous exercises, we learned the threshold, which decides that when will the model make a prediction in the positive class or the negative class. So you need to choose a particular threshold, classification threshold. Beyond that, for example, an email, spam email. So beyond the threshold, that spam email is classified as a spam, and below that, it is not classified as spam. So you choose a particular threshold, but in that classification threshold we picked up one threshold, 1 point. But in this ROC curve, this is a visual representation of a model performance across all thresholds. So this curve that you see, so this is a model performance, how well the model performs across all threshold. For example, let's suppose that we choose a threshold 0.1. Now what is the performance of the model? We choose a model 0.2, 0.3, 0.4, 5, 6, 7, 8, like all the possible threshold in a continuous scale. If you see, so how it is drawn is by calculating the TPR, true positive rate, and FPR, false positive rate, across all possible threshold, but in reality at selected intervals. Then graphing TPR over FPR. So this is TPR 0 to 1, FPR 0 to 1, and this is AUC, area under curve 1. So a perfect model which at some threshold has a TPR of 1 and FPR as 0 can be represented by either a point at 0, 1 if all the thresholds are ignored, or by the following. This is a figure for a hypothetical perfect model where the TPR and FPR are 0 or 1. Now moving on to the next, AUC, area under the ROC curve. So this represents the probability that the model, if given a randomly chosen positive and negative examples, will rank the positive higher than the negative. What it means that looking at the spread of data point below, what it means that looking at the spread of data points below, AUC gives the probability that the model will place a randomly chosen square to the right of a randomly chosen circle, independent of where the threshold is set. Now we will take example of the spam classifier. Now in the spam classifier example, if we pick an example of, okay, in the here the AUC was 1, but this is a figure where AUC is 0.5. So what happens if AUC is 0.5? It means that it assigns a random spam email a higher probability of being a spam rather than a random legitimate email only half the time. So if we think about the AUC, it gives a probability uh, curve, what is the area under the ROC curve, but it generally denotes what is the probability based on the data set that we provide, how well the model will rank the examples that we have, positive example or a negative example. Okay, let's read a bit more. AOC and AOC, okay, yes. The nature of data set. Yes. AUC and AUC and ROC only work well when the data set is balanced. The data set contains positive classes and negative classes. So if data set is balanced, then only you can pick these metrics AUC and ROC curve and check whether what is the performance of the model. But when data set is imbalanced, there is another metric called precision recall curve, and the area under those curves may offer better comparative evaluation of the model performance. So this is PR AUC, precision and recall. What is the area under this? Okay, moving on. Okay, AUC and ROC for choosing model and threshold. AUC is a useful measure for comparing the performance of two different models. Yes, as we explained, that AUC is a useful metric when we want to compare the performance of two models, but only when the dataset is balanced. So this is comparison of two of the models. This is the first graph of AUC. This is second one. So ROC and UC have two hypothetical models. The curve on the right with greater AUC represents the better of the model. So this is a better curve. It represents a better model performance. Okay, anything else that we want to see? And also, yes, if false alarms are highly costly, it may make a sense to choose a result that gives a lower FPR like the one at point, if even if TPR is reduced. So it only explains that what point do we choose, because in some scenarios false alarms are costly, or in some scenarios false alarms are uh, cheap. Now, what is false positive? What does it mean, costly and cheap? It means in certain scenarios, for example, let's say we are detecting cell and confirming, giving a probability that what is the percentage of the confirmation that classification we are doing, that this particular um, cell or the example is a cell is a cancer. So here providing a negative or a false positive is highly costly because it has a very large cost. So model or the evaluation that we are doing or training we are doing, the metrics we choose, it is based on those scenario. We uh, give the false positive a higher proportion, a high, keep that cost a high. So that is what it means, that false positive has a high cost. Like so I'm comparing this medical scenario to the spam email example. Now in the spam email, if some spam email, or even if some genuine emails are classified as spam, or if some emails are classified, some spam emails are classified as genuine, it does not matter much. Or so that is why false positive is a very is a low cost here, but in the medical scenario it is a high cost. So based on the data set, there again we can decide the threshold, and we can see what is the ROC curve here. So let's say I increase the threshold. So I increase the threshold, then my ROC curve, which is TPR over FPR, goes to 0. Now if I bring into the start lowering it, this we've already seen confusion matrix, the 2 cross 2 matrix based on the 4 outputs that is design, and this is the matrix accuracy, precision, recall. Okay, now let us check our understanding. In practice, ROC curves are much less regular than illustration given below, given above. Which of the following model represented by their ROC and AOC, ROC curve, and the AUC has the best performance? Okay, we just saw that if model which has a high ROC curve is a better model. So in this, I think okay, so these are four models. So here, which one has the highest AUC curve, we see that I think this one is the highest. Yes. So this model has the highest AUC, which corresponds with the best performance. Okay, now next question. Which of the following models perform worse than chance? Okay, again this is UC and ROC, but the question is that which is the worst model than chance? Chance means any random sample. So which is worst model? This is the perfect model where TPR or PR both are. AUC curve is 1, so that is a perfect model. This is 0.5. I think it is the lowest, so this should be 1. Let's see. Yes. So this model has AUC lower than 0.5, which means it performs worse than the chance. So this model AUC is zero point 0.5. It is more than zero point 0.5. Okay, let's read what are the optional advanced question. Okay, which of the following changes can be made to the worse than chance model in the previous question to cause it to perform better than the chance? Okay, have it always predict the negative class, have it always predict the positive class, reverse the prediction, so prediction of 1 becomes 0 or prediction of 0 becomes 1. If reverse the prediction of 1 becomes 0, so that is not. I think if you increase the total positive rate, so that means it has to always predict the positive class, then the chance of this AUC curve is that it will increase. Okay, that's not correct. This may or may not improve performance above chance. Also, as discussed in the question section, this is not a useful model. Okay, let's check this third paper. Okay, again, this is so this should be the correct answer. If a binary classifier reliably puts example in the wrong classes, more often than the chance, switching the class level immediately makes it prediction better than the chance without having to retrain the model. Okay, you change the label, so the prediction becomes better without retraining because it is performing opposite to what we are expecting. And if we reverse the label, then the prediction becomes better. Okay. Okay, let's solve this one. Imagine a situation where it's better to allow some spam to reach the inbox than send a business critical email to the spam folder. You have trained a spam classifier to the situation where the positive class is spam and negative class is not spam. Which of the following points on the ROC curve for a classifier is preferable? A, B, C. Okay. Okay, if we think about this, where the positive class is spam and negative class is not spam. So the lower the I think our AOC curve in the points A, B, C, better will be our spam classification. Why? Because the situation is that it is better to allow some spam to reach the inbox than send a business critical email. That means that the positive rate, the total positive rate, may be some lower or less costly than the false positive rate. If we compare this TPR with the FPR, so it just this situation is given to allow us to judge which is more costly, the TPR of the F or the FPR. So in this case, I think it is TPR that is more costly, not the FPR. Why? Because FPR is you see the situation, it is allowing some spam to reach the inbox, but you could not send a genuine email to the spam. So that means a TPR is more costly. So that means that if our TPR has to be a very high. So I think in this case, if you think the highest point for this would be, I think C or B. Let's say C. Okay, that's wrong. This threshold maximizes the true positive, flags more spam at a cost of more false positive. More legitimate email flagged as a spam. Okay, then would be point A would be correct. Okay, in this case, it's better to minimize false positive when is true positive also decrease. Okay, I've not understood this perfectly. I've understood the question, but this point of point A, B, C. Okay, this balances the true positive and negative. Okay, and what does the point A does in this use case? It is better to minimize. Okay, that size not better to minimize. Okay, in the next we will read prediction bias, and also I will read more about this curve. And in the next video, maybe I can attempt some different question, related product, or continue uh, reading this or learning about machine learning. That's thank you.